This one, what happens when you plug it into power, nothing happens at all, like there's no sign of life at all. So I smelled it, and I smelled a little bit of a magic smell. Turn it over and you can see this trace is destroyed. This comes from the yellow wire remote or something like that. But basically it's, you know, the main power line. And it's blown to bits. I already kind of pulled it off of there. So usually when that happens, most likely it's going to be the audio output chip here. I'm trying to get the number off it. Let me see if I can remove this thing. Alright, I don't know how well you can see that, but that says T8266HQ. So I gotta get my hands on one of those things and put it in and see what happens, because that's what most likely caused the trace to blow. You can see some crud there on the left of the pins right there. So normally when you get a short like that, the fuse is supposed to blow. But how much you want to bet there's like either a giant hunk of wire stuck inside this thing, or like a ridiculously overrated fuse in here. Guaranteed. Yep. Look at that. That's why the trace blew. This is no longer a fuse, the trace was a fuse. So just to sort of 100% confirm that it was the chip here that blew, I'm going to just do a continuity check between the positive inputs of this thing and ground, and there should be one there, and then I'm going to desolder this and measure again, and if, you know, the continuity is gone, the short is gone, then obviously that's the problem. So I'm just going to do a continuity check. This is the positive rail here, and this is the bottom of this filter capacitor in here, and this is the positive of that capacitor from the positive rail, and this is ground here, the negative of the capacitor. So I'm just going to do continuity check between the two. Come on, it's kind of hard to do this one-handed, but it's just straight up continuity. Dead short. It's easier to just stick something under the pins and lift them up as you heat the bottom of the board. And I'm just using a high-tech component puller here. Very expensive piece of equipment, but definitely worth it. So just pull them up like that. They get kind of beat up, but that's okay. Just be careful with them in case the part's actually good. You can put it back in without damaging, you know, breaking off one of the pins or something. So here it is. Came out. Not the neatest way of doing it, but I'm just doing this for fun basically, so who cares. Okay, so hopefully now you can see that the short is gone. Let me see if I can do this one-handed. No more continuity. You can see the capacitor is charging. So the short's definitely gone. Problem was the audio output chip, or IC or whatever. So I'm just gonna sort of loosely check around, you know, any surrounding component or related components. You can see some damage there from when it blew up. Looks like it spilled its guts out from the bottom here. So, you know, just check anything that might be related there, just in case that caused anything. We see some capacitors here and stuff. So I'm just going to give that a quick check, and hopefully everything's good and we can drop the new part in and it'll be good. So here's a new audio output IC, put it back in place, soldered onto the board with the heatsink in place and everything. Also soldered back these leads here. I had to use a different part number because I couldn't find the original one. It's TA8266, and I found some equivalents for that. Just sort of found some possible equivalents and went pin by pin to see if they matched. This is the original TA8266, 35 watts, and the best match for it overall that I found was TA8264, which is a pin by pin match, except this one gives you 41 watts, which is 6 watts more than the original, which is 35 watts. So this should work perfectly fine, except you'll get 6 watts more power. You might need to bump up a fuse or something, but it should work perfectly fine. The other equivalents are TDA 7384, TDA 7385, and TDA 7386. The best match overall is going to be TDA 7385. It's almost a pin by pin match except for pin 16, and that goes for the 3 of these TDA ones. Pin 16 isn't used for the same thing. On the originals, pin 16 is called aux in, and I believe what this is that when you click through the menu, some stereos have like a beeping sound when you click on stuff through the menu and all that, and that beeping sound or whatever sound effects it has are fed through this pin 16 and they come out of the speakers. So these ones don't have that, but it's not a huge deal. You know, personally I don't even like those beeping sounds, so that won't work if you use these TDA equivalents, but it doesn't matter. You know, it's not a huge deal. The thing is though that on these ones, the TDA ones, pin 16 is used for something else called AC ground, and pin 16 needs to go to ground through a 0.47 microfarad capacitor. So you're going to have to do that, and that's what happened to me. I used TDA 7386, and pin 16 isn't used for the same reason as the original. So I forgot to check that before I installed it, and I had to lift up the pin, which was really difficult, without desoldering this whole chip, because I thought I would break off more pins and stuff if I did that. So I just, with it in place, I lifted up pin 16, and it ended up breaking off, but luckily I was able to solder a piece of wire to the stub that was left, which was a pain in the ass, but I managed to do it. And I just ran this little wire here and send it to ground through a 0.47 microfarad capacitor. If your stereo doesn't actually connect anything to pin 16, if you're using like a TDA 8266 or 64 or whatever, but pin 16 is not connected anyway, you're still going to have to send it through ground if you use a TDA replacement. But in that case, you don't have to actually lift off the pin, and you can just solder the wire at the bottom of the board where it solders onto, you know, because it's not being used anyways. Just grab it from the bottom of the board and send it to ground through the capacitor there. So that's what I did. The thing is though, TDA 7385 is the best match of these TDA ones except for pin 16. You can also use TDA 7384, which is 35 watts, and TDA 7386, which is 49 watts. And they're also a close match except for pin 25. These two here, TDA 7384 and TDA 7386, don't use pin 25. It's not connected. And on these ones, the TA ones, that's called diagnosis. And what diagnosis does is it outputs information to the microprocessor regarding what's going on with the audio output IC. So if like there's a bad connection or anything like that, a short circuit at the speakers or something like that, this sends information out through pin 25 to the microprocessor to let it know what's going on and if it should auto protect or something like that. You can get away without using that. You know, in my case, the stereo, even though the original chip had a diagnosis pin, it wasn't actually connected to anything. So it didn't matter when I used 7386, because 7386 doesn't have a diagnosis pin, it's just not connected to anything. But the stereo also wasn't connecting to anything on pin 25, so it doesn't matter at all. So of course all this cross-reference crap is just if you can't find the original part, or maybe you want to put one in that gives you more power or something like that. You know, which was my case. I just happened to have a 7386, and I just wanted to make it work with that. And of course, in my case, the stereo actually was using pin 16 on the original chip for its intended purpose. So in my case, I actually did have to lift off the pin on this TDA 7386 replacement to be able to send it to ground properly through the 0.47 microfarad capacitor, you know, because I couldn't have it hooked up to the microprocessor like it was, you know, on account of the difference between the original and the replacement. But if in your case the stereo uses a chip where pin 16 is an aux in pin, but it's not actually being used and it's just floating there and it's not connected to anything, you don't have to lift off the pin. You just have to, tack it to the bottom of the board somewhere, tack a wire to the bottom of the board and do the little mod here with the capacitor. That's all you have to do. No need to lift off the pin like I did if it's not actually connected to anything in the board. Same thing here in my case, pin 25 wasn't being used at all, so the fact that this replacement chip doesn't use that pin didn't matter because the stereo doesn't either. So let's power this thing on and test it out. It's working pretty well. This knob is a little bit dirty. I might need to clean it with some contact cleaner. Unless it's optical, then I might need to clean it, dust it off or whatever. So it's sounding pretty good. Yeah, that thing needs cleaning because the volume's just jumping around. The other thing, if you're going to use a higher power chip, like I said, you might need to upgrade the fuse to handle the extra current draw. The other thing is, if the trace that feeds the voltage into the original chip is a little bit too wimpy, you might need to reinforce it with a piece of wire. And the other concern would also be temperature, extra temperature, and cooling factor. It might not be a good enough heatsink for the bigger power chip or something like that. But that's just how you can repair a common problem with these stereos. When it's blowing a fuse and stuff like that, usually it's the audio output I see. That's probably the most vulnerable part in this thing because people hook up stuff wrong and all kinds of crap. So that's how you can repair these stereos if you have that symptom. This is probably what it is, and also in the process you can probably even upgrade the power output on this thing. Right now I'm going to add some hot glue to this capacitor here. This isn't a very fancy place to be putting this because of vibration and stuff. This being a car stereo, you have to take into account vibration, so I'm going to hot glue this in place so it's nice and still. But there you go.